I'm Joshua Bardwell, and today I'm going to take you through the steps to build an FPV quadcopter with the DJI HD FPV system. My tagline on this channel is, you're going to learn something today. I want you to learn something new with every single one of my videos, and this is going to be an easy one because the DJI HD system is new to pretty much all of us. And it's especially new to people who are coming into the hobby who have never been a part of FPV before. And I think that's one of the really great things that the DJI system is making happen. So many people who have no interest in FPV, or maybe people who tried FPV but were super turned off by just how crappy analog video looks. So many people are getting into FPV because the DJI system makes it so awesome to fly in high definition. So whichever one of those you are, whether you're experienced with FPV and you just want to know how to integrate the DJI system into a quadcopter build, or whether you are brand new to FPV and you've never built a quadcopter before and this is your first one, welcome, let's get into it. Before we get into the build, I want to let you know, this build is coming out in several parts. There's a playlist down in the video description with all of the parts of the video in it. And if you are an experienced quadcopter builder and you just want to get into the DJI stuff, I'm going to call those out in the playlist in their own separate videos so that you don't have to watch me like solder up the motors like you already know how to do. So go take a look at the playlist. The DJI specific stuff is called out. But for anybody who's brand new to the hobby, let's start building a quadcopter. Here are the parts that I'm going to be using in this build. There are links to all of these parts down in the video description. You can click those links and buy all this stuff if you want to follow along. You don't have to be using this exact stuff. For example, if you choose to use a different frame, you'll probably be able to follow along. If you choose to use different motors, nothing's really going to change about the build. The only thing that you really should stick with if you really definitely want to follow along exactly with this build is the flight controller and the ESC. If you go with a different flight controller or ESC, well, if you're an experienced builder, you'll be fine. But if it's your first time, you should probably stick with this one. And the first thing we're going to start with is the frame. The frame we're using is the Rotor Riot HD1. The frame is basically a bunch of carbon fiber parts that hold together all the other stuff. Here's this little baggie of odds and ends, screws and standoffs, basically. Just going to dump those out. We're going to get out these plates here. This is the top plate. We can set that aside. This is the bottom plate, and this is the X plate. We're going to take the bottom plate. We're going to take the arms, and we're going to go ahead and install these and assemble these. The bottom plate has a top and a bottom. The top has some press nuts in it, and we're going to want to turn that over and approach from the bottom. In the hardware kit that came with the HD1, there are two lengths of screws. There are long ones and short ones. We're going to get the 8 long screws and set them aside. We're going to get the base plate, and we're going to get the arms. And I want to point out to you that the screw holes on the arms will line up with the press nuts on the base plate. If you install the arm upside down, this screw hole will not line up correctly, so you just flip the arm over. What we're going to do is we're going to take the X plate, we're going to insert 2 screws, like so. We're going to put those screws through the arm, like so. And we're going to install those screws in the press nuts. I'm using a 2mm driver. If you need a driver set, you're going to be building quads, you definitely want a driver set. There are links to all of the tools that I use for my builds at my website, www.fpvknowitall.com. There's a whole section there with tools, and there's a driver set on there as well. I'm just going to loosely screw these in for now, and I'll tighten it up when I'm done. So I've got this one backwards, you can tell, because this screw hole is on the outside. We'll flip that over so it's on the inside, and that'll be correct. Now I can tighten these down all the way. Do be careful not to strip them. If you over tighten them, you can strip the screws, or you can strip the press nuts. You don't want to do either of those things. Okay, and this is the base on which we're going to build the whole rest of our quadcopter. The motors that we're using are Rotor Riot Hype Train Blaster motors. These are 2207 in size and 2450 in kV. And if you don't know what all that means, don't worry about it. 2207 2450 kV is a great all-around starter size for a motor. Great for freestyle or racing, at least as a beginner. You'll be very happy with these. The nice thing about the Blaster motors is that they come with a replacement program. If you smash them for any reason, you can get a replacement for, I think there's like a handling fee or something, but basically they come with a warranty, basically. Kind of cool. The screws that come with the Blaster motor are not the right size for the arms that we're using on this build, and I believe that Rotor Riot has become aware of this, and I believe that by the time you see this, they will be shipping the frame with longer screws. But you can see that these screws just barely stick through by a half a thread. They're not going to do the trick. I am going to have to dig into my pile of supplies to find screws that will work, and I hope that by the time you're watching this, you won't have to do that. That's really what you want to see, that the screw is just about flush with the base, or maybe a half a thread past the base. But what you don't want to see is you don't want the screw to extend in and touch the windings of the motor. That will destroy the motor. No joking. It can just destroy the motor. The screws that I'm using here are cap head M3 screws, and they use a 2.5mm driver. I do like using cap head screws for motors because they take a little bit of abuse being out there on the end of the arms. When you land the quadcopter on maybe some asphalt, they'll get tore up, and the button head screws used elsewhere, they'll flatten out and get stripped off really easily. These guys are a little more durable. When you install the motor, you're going to want to install the motor with the motor wires facing down the arm. Now all 4 motors are installed, and I do want to point out, you may have noticed I only used 2 screws on each motor. You should use 4. I am only using 2 because I'm having to dig through my spare parts pile to find screws of the right length. You should use 4 on each motor. That's more secure. Some people think they're saving weight by only using 2 screws. You're not saving that much weight, folks. Until now, pretty much everything you've seen so far has been pretty self-explanatory. There's a frame and there are motors, and you know what those things are. This right here is an ESC. It stands for Electronic Speed Controller, and the motors that we've got are a type of motor called brushless DC motor, and that kind of motor needs an ESC to make it spin. Basically, the ESC sends carefully timed electrical pulses through the motor wires to cause the motor to spin. So this is an ESC, and this is a type of ESC known as a 4-in-1 ESC. You basically need 1 ESC per motor. So once upon a time, you would put 1 ESC out on the end of the arm with the motor, but then somebody had the clever idea to take all 4 of the ESCs and put them on a single board, and that's what we're looking at here. This is a 4-in-1 ESC. Now, our ESC is from Newbie Drone, and that's because our flight controller is also from Newbie Drone. What's a flight controller? The flight controller is the brains of the quadcopter. It takes the commands from you and it tells the motors what to do to make the quadcopter fly. And an ESC and flight controller, it's very convenient when they come from the same company and are compatible because it saves you a lot of soldering and wiring. You just plug them together and they just work. The reason we're going with this Newbie Drone flight controller is that it is designed to be used with the DJI Air unit. So the Air unit has certain requirements for power, for how it connects to the flight controller. And when we get to this part of the build, I am going to show you how to solder up the air unit if you are not using a flight controller that's designed to automatically connect to it. But if you're following along with this build, you can use the Newbie Drone flight controller and the DJI air unit will just plug right in. So the mounting hardware it comes with, these are nylon screws. I don't like this and I'm not going to use these. You can use these if you want to, and it'll be okay. But nylon screws, when you have a hard crash, they shear off and they break, and I don't like to rely on them. Now, there are various ways to approach this problem, but I have got an M3 screw assortment. And these are M3 cap head screws, and I'm just going to dig through and find the screw that is the same length as the ones that came with the Newbie Drone kit. There we go. And I'm going to use these metal screws instead. If you don't have these handy, you don't have to use them. If you want to get a screw assortment, they are... I don't think this exact assortment is on my shopping list. Maybe I should fix that. But here, I'll show it to you. M3 metric screws, 550 pieces, up to 30 millimeters, down to 5 millimeters. Cap head, it's a good kit. Now this frame comes with screw holes for a 30 millimeter and a 20 millimeter size flight controller. And this is a 30 millimeter size flight controller. You can see here, it's going to match the outer holes. So these guys are going to go just in there. Now let's just eyeball this because I think we're going to need to put some spacing. So what I'm going to do is install a M3 screw or nut, M3 nut here, and that's going to hold the screws in, and it's also going to provide just a little bit of spacing, you see, so that when the ESC comes down on here, the ESC won't touch these screws. That's important because the ESC has electricity flowing through it, and when electricity touches metal, the electricity gets out and things light on fire and you blow your $60 ESC, and that's bad. So now we have 4 nuts installed. I'm going to go ahead and put this ESC on, but hang on, I want to put it correct, facing the correct direction. The back of the frame is this curved part with the holes in the middle. The front of the frame is this flat part. Yes. And the ESC, this part of the ESC is going to face the back of the frame. I'm just going to push that down over the top here so that it comes down and rests on the screws. And check our clearance here, and you can see we have plenty of clearance. That's good news. Does this just go right on top? I doubt it. We need standoffs. We need spacers. Oh, it does go right on top. Holy crap. Oh, wow. That is mighty slick. Well, you know, I was about to say, oh, we need some spacers to put the flight controller on top, but actually it looks like the flight controller just settles right on top. It's got plenty of room there. It's got a flat bottom with no components on it, but I'm gonna put a spacer on there. Oh, they give you enough nuts to use as spacers. Yeah, that's a good idea. Just get a little airflow. Now I'm not gonna cinch that down super tight because the ESC and the flight controller have little rubber gummies, they're called, and that provides some vibration isolation. So you don't want to squish those gummies down super tight because it'll crush them and prevent them from isolating as well. Just get those down mildly snug. Next, I'm going to install the flight controller, and when you install the flight controller, make sure you have the USB port facing to the left. Good. And I'll go ahead and put some nuts down on the top of here. Looks like I could have used a slightly shorter screw. That's okay, I guess. Not the end of the world. Now we come to the part of the build that is going to trouble some of you. And it's because it involves soldering. If you have never soldered before, because you're coming from like a DJI background and you're used to just not having to build your own stuff, I'm sorry to say that this is the part where you should stop. You should go and learn to solder. Because if you charge ahead without knowing how to solder, you're just going to destroy stuff. Your quads will fall out of the air. You're going to damage your equipment. You have to just learn to solder. And this is not a soldering 101 video, or it would be 7 hours long, right? We just have to talk about nothing but soldering. So I'm going to charge ahead. On my Ultimate FPV shopping list website, I have suggestions for soldering equipment you could use. You don't have to have an expensive soldering iron, but there are good ones and there are ones that will only get in your way. And they're going to put some links down in the video description to some videos that could help you learn more about soldering technique. But the bottom line is, this should not be the very first soldering you've ever done. If it is, you are not going to have a good time and you're going to destroy expensive equipment. Moving on. The soldering iron I'm using is a Hakko 888D. It is on my Ultimate FPV shopping list. It is set to 750 degrees Fahrenheit, and the solder that I'm using is 6040 rosin core leaded solder. Don't use lead-free solder unless some places like in Europe it can be just impossible to buy lead-free. Leaded solder works way better, and the amount of lead in it is so small you don't need to worry about it. The first thing I'm going to do is I'm going to tin these pads, and that just means to coat them with a small amount of solder. And these are the motor output pads. There we go. I'm going to tin these, which are going to be the main battery pads. And if you have trouble getting the solder to stick to the negative pad here, that is the hardest pad to solder to because it has a lot of thermal mass. The ground plane is a lot of thermal mass. If you have trouble getting that to stick and your solder doesn't just flow neatly onto that pad just like mine did, that's a sign that it's only going to get harder from here. You want to stop, you want to back up, you want to figure out what is wrong with your soldering technique or your soldering equipment. Because soldering is, when your equipment is set up right, it doesn't take much technique to solder well. It takes a little, but not much. And so if soldering is hard, it means that probably your equipment is not set up right. You're not at the right temperature. You're not using a good soldering iron that's getting hot enough. Or you could have bad technique. It should be just that easy. I am not, ask any of my commenters on my YouTube videos, I am not an expert solderer. I am a competent solderer, and it just should be that easy. Now the motor wires here are just about the right length. I'm going to be lazy and I'm not going to cut them to length. I'm going to just, you'll see what I do. But the next thing I'm going to do is I'm going to tin these wires. The wires come from the factory pre-tinned, but they're tinned with lead-free solder that factories have to use. I'm going to add some fresh leaded solder with rosin core. We'll get some flux on them, and that'll make this easier. The next thing I can do to make my life easier is apply some flux. This is liquid electrical flux, and it comes from SRA solder. That's just the one I happen to have. And this is a magical chemical that will make your soldering a lot better. It will make you into a much better solderer if you apply some flux. There is flux inside your rosin core solder, but this is more flux, and that's a good thing. The order that you connect these motors to the 3 motor outputs doesn't actually matter. It turns out that you wire them up one way and the motor spins clockwise. You wire them up another way, the motor spins counterclockwise. And there's not really a way to know beforehand which is which. So I just go ahead and just wire them up straight through. So this wire is going to go to this motor pad. This wire is going to go to this one, and so on. 1, 2, 3. That just makes them look neat. We're going to fix the motor direction later in the build. Hey guys, it's Joshua from the future here. And after finishing the build, I realized that there is something that I would change if I were to do it again. If this is your first build, just don't worry about what I'm about to tell you. But if you're a little bit more experienced builder, or if you just feel particularly adventuresome, this is what I would change. The problem with the way that it's sort of done is, you see how the battery lead is pressing against the wire coming out of the air unit? Now, I don't like that, but it probably would be fine, and I would probably live with it. In fact, that's why I just continued with the build as it is. But the other thing that I don't like is that there is nowhere to retain this battery lead. In other words, if your battery strap gives out in a crash, your battery goes flying off, it's going to yank on this battery lead. And eventually what will happen is it'll just rip the pads right off and ruin your ESC. So I always have some kind of retention for my battery lead, and normally I would tie it to a standoff, but there isn't a standoff here. So if I were to do this again, what I would do is I would flip the ESC 180 degrees around so the battery lead comes out the front, and I would zip tie the battery lead to this standoff. That helps keep it out of the way of the props, and it provides stress relief, strain relief, in the event that the battery ejects in a crash. But if you do that, the motor order will not be correct, and you will need to go into software in the flight controller and reorder the motors. Now that, I have a video explaining exactly how to do that, and I'm going to link it down in the video description below. If you feel adventuresome and you want to do that, that is, I think, a much better way to do it than the way that this is done. If that scares you a little bit, or you just don't feel like going through the hassle, this will probably be fine 90% of the time, but you should definitely use 2 battery straps, not 1, just to help make sure that your battery never ejects. And definitely use some grippy battery pad like this Grip, and that will help protect you. Okay, on with the video. Now, when you've done this, there are a couple things that you must check. One is that there is no solder bridging between these 2 pads. If there's any wire strands sticking out or lumps of solder or anything like that that is bridging between these 2 pads, you will destroy your ESC when you try to fly, and that'll be a bad time. The other thing you want to check is that there is no solder bridge between the motor wire and this metal cover here. If there's any solder connecting those 2 things, something bad will happen the first time you go to fly. So here I've got the 3 motor wires for this motor connected to the 1, 2, 3 motor pads here, and that's it. I'm going to need to do the remaining 1, 2, 3 for the back left motor, 1, 2, 3 for the back right motor, and 1, 2, 3 for the front right motor. I'm going to go ahead and do that off camera. Now all of the motor wires are soldered to the ESC, and again, this is a good time to double check that there are no bridged pads and that there's no solder going to the metal cover. Now we come to the XT60. This is the battery connector. It's called an XT60. It's rated for 60 amps. That's why it's called an XT60. And you can purchase one pre-built. I'm going to link down in the video description to a pre-built one you can purchase. It's going to come built and tinned, and you can also just build your own it's cheaper to buy your own silicon wire and your own XT60 connectors. You can build a lot of them, but I'll link to the pre-built one that you can get. And you're going to want to go ahead and tin that. A little bit of flux to help the solder flow and to help transfer heat. This is 14 gauge silicon wire. If you want to source your own silicon wire, doesn't mean that the wire is literally made of silicon. It's copper wire, but it's silicon insulation, and it's fine stranded copper wire. This, you can see, it's very fine stranded. This is good for vibration prone environments because any thicker strands of copper would work harden and crack. So you don't want to use just hardware store wire for this. I'm just going to go ahead and tin this. Good, and coat it with shiny silver solder. Say that 3 times fast. Well, I've just noticed that positive and negative are not marked on the top of this board, and normally I would assume this thing here is a shunt resistor for current sensing, and I would normally assume that that would mean this was the positive pad, but I would be wrong. The positive is this one and the negative is that one, that is not what I would have guessed, and I'm glad I checked. Newbie drone, mark positive and negative right here on top of the board, because, you know, obviously. So now you would probably be tempted to just run this straight out the back. That's not a terrible idea. That's not a bad idea. I usually like to do mine coming out the side. And the reason is that if you do it coming out the back, then it just runs through the whole back of the quad. There's not really any reason to do that. It just takes up extra space and gets in the way. Add some flux to this before I solder. And I'm going to go ahead and turn my iron up to a higher temperature. I'm going to run it at 850 degrees for these larger wires. I like to run it as hot as possible. There are soldering experts out there who will tell you that that is too hot, and they are probably right, especially if you're a beginner. You don't want to run super hot. You can easily get yourself in trouble and damage things, but that's what I'm going to do, and I'm going to be honest with you that that's what I'm doing. And I want to show you very clearly that what I've done here, I've been very careful not to let any metal part of the positive make any contact with any metal part of the negative. Make sure they do not overlap at all. And here we are. We are making progress. The next thing I'm going to do is I'm going to dress these wires neatly. Now there are various ways that people go about doing this. I just like to use electrical tape. It doesn't look sexy. It doesn't look fancy. But that's just what I like to do. My philosophy is that you don't look at the quadcopter while you're flying it, so I don't really care how it, I try to make it functional more than pretty. And I care about how it flies more than what it looks like. What I'm going to do is I'm going to take these wires and I'm going to put them along the back edge of the arm. Now you might think, well, why don't you just run them on the top of the arm? Isn't that better? The reason is that if your prop gets bent, your prop can strike the arm, and if the motor wires are on top of the arm, they can get cut. You might think, well, why don't you just run them on the underside of the arm? Well, because then when you're landing, you'll be damaging them potentially. So I'm just going to run a little bit of electrical tape like so to... I don't like that. Just make sure there's not too much tension on any of these wires. We got plenty of slack, so definitely use it. Give it a little bit of room to flex, but keep them snug and secure. I'm going to go ahead and do the rest of them that way. Okay, so we've got the motors installed. We've got the ESC installed, the battery lead, and it actually gets way freaking easier from here. This wire comes with the ESC, and it is going to plug into this plug right here in the front. It is keyed. It has little tabs that prevent you from installing it backwards. So insert it gently. If it doesn't want to go, flip it over. And here is the flight controller. And that's going to get plugged into this plug on the flight controller, which also is keyed. So if it doesn't want to go in, just flip it over. Like so. Be a little gentle plugging those in. If you're a little rough with it, you can just break the dang thing off. And we're going to go ahead and install the flight controller on top of the stack. And you know what I'm going to do here? I'm just going to give this a couple little twists to make it take up some of the slack and make it just a little neater. There we go. Okay, that's a whole lot of soldering that you didn't have to do. And frankly, this is a good point to sanity check your build before you start putting your expensive DJI equipment on it. And in order to do that, you're going to need two things. You're going to need this. This is called a smoke stopper. I have a video about what this is and how to make one. These are very, very helpful. They will prevent certain types of faults from destroying your equipment. And this is a multimeter. If you don't have one of these, you need one. You don't need an expensive one. Even a little $10 dime store Radio Shack one will work. I'm going to put this into continuity mode. And I'm going to test for continuity between the battery leads. And it should not be there. If you get a beep and continuity shows continuity between the battery leads, don't plug a battery in, you got a problem. But we don't have a beep, so that's good. Just to be extra safe, I'm going to plug my smoke stopper in, and I'm going to get a battery, and I'm going to plug a battery in. This is a 4-cell 1500 milliamp hour LiPo. if you're coming from the DJI world, lipos are a lot different on mini quads. We're going to plug this in. We're going to cross our fingers. Excellent. And what we want to see is, we want to hear those beeps. Doot-doot-doot, doot-doot. We want to see the motors twitch, or you can, if they don't visibly twitch, you can pinch them with your fingers and feel them vibrate. We want to see all 4 motors do that. This one isn't doing it. Let's try it again. There it was. Yeah, I can feel it. Okay, that's very good. And of course, we want to see the lights. Come on. I want to see this little light go blip, 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 blip. That little blink sequence that you saw that LED do, that's all. Those are all signs that things are working correctly. Fantastic.